Chapter 5, Ions and Ionic Compounds. Chapter 5, Section 1, Simple Ions. In this section, we are going to look at the formation of monatomic ions, so ions that are made up of only one atom. In order to talk about the formation of ions, we need to understand chemical reactivity. Remember that chemical reactivity is based upon our discussion of electron configuration. We are going to look at two elements. We're going to start with oxygen. Oxygen has an electron configuration of 1s2, 2s2, 2p4. If we recall from electron configuration discussion, we know that p sublevels can hold a maximum of 6 electrons, and oxygen only has 4 electrons in its p sublevel. This tells us that oxygen can obtain 2 more electrons to have a filled p sublevel. Since it needs those electrons, it makes it very reactive. The other element we're going to look at is neon. Neon has an electron configuration of 1s2, 2s2, 2p6. So its p sublevel is completely filled. It has no reason to obtain more electrons. And because of this, neon shows no reactivity. Neon is a member of group 18. Group 18, remember from chapter 4, is a noble gas. Noble gases are the least reactive elements on the periodic table. The reason why is because they have a filled outer energy level. In other words, their S and their P sublevel and the highest main energy level is filled. These elements show almost no chemical reactivity. At one time, we thought that they did not react at all. We've recently discovered we can actually force these elements to make compounds. For example, xenon can make compounds with fluorine. So our discussion today is about the formation of ions. Ions are formed so that we can obey the octet rule. The octet rule states that atoms tend to match the s and p electron configurations of the noble gases. In other words, they're going to lose electrons or gain electrons to look like a noble gas. Metals are going to lose electrons and form positive ions. Nonmetals are going to gain electrons and form negative ions. A really great example for us to look at is a metal, sodium, and a nonmetal, chlorine, and them combining together to make a compound. So let's look at the following video clip.
Sodium metal is heated until it melts and just begins to burn. Then it is immersed into the yellow-green chlorine gas. The sodium begins to burn in chlorine with an intense yellow flame. It produces a white smoke of sodium chloride. We are observing the exothermic reaction of sodium metal with chlorine gas, producing the white solid sodium chloride. Afterwards, the glass spoon contains only white solid sodium chloride.
Okay, so in the video we saw sodium, which is a group 1 metal, reacting with chlorine. Chlorine comes from group 17, which is the halogens. You can see that this reaction is very reactive. So let's talk about some of the reasons why. Sodium is a group 1 element, so it has only one valence electron. Sodium very easily gives up its one valence electron, which makes it very reactive. And now it has obtained the noble gas configuration of neon. Chlorine is in group 17, which has 7 valence electrons. It needs to just obtain one more electron to have the noble gas configuration of argon. So this makes it also very reactive. Remember that we can easily obtain the number of valence electrons by looking at the location of an element from the periodic table. For example, if we look at phosphorus, phosphorus has an ending electron configuration of 3s2, 3p3. And we know from our previous discussions that if I add the electrons in s and p together, that this would give the total number of valence electrons. So in other words, phosphorus has 5 valence electrons. 2 of these come from 3s, and 3 of them come from 3p. So remember that the group rule. So in groups 1 and 2, the group number tells us the number of valence electrons. In groups 13 through 18, it is the group number minus 10. So phosphorus is in group 15. If I subtract 10 from the group number, this also confirms that phosphorus has 5 valence electrons. The last group of elements we want to talk about forming ions today are the transition elements. And so the transition elements behave like all metals. In other words, they lose electrons to form ions. Remember that whenever you lose electrons, you form a positive ion known as a cation. Now, unlike the other metals of the periodic table, transition elements have the ability to form ions that do not necessarily have a complete octet. And for this reason, they can have multiple charges. So in a second, we're going to look at the figure from your book on page 163 and the number of ions that some of the transition elements are able to form. One thing to note, the way that we differentiate one ion from another in terms of naming is to use a Roman numeral that tells us the charge. So if we look, we have copper, Roman numeral 1, that tells me that copper has a +1 charge. And then we see copper, Roman numeral 2. This tells me that this copper ion has a +2 charge. So this is the figure from your book on page 163. And as you can see, remember that the transition elements are found in the D block. They're groups 3 through 12. And the majority of them form multiple ions. You will not need to memorize the ion charges for the transition elements. We would instead, there would be a Roman numeral followed by the name to let you know what the charge would be.